Hello, my name is Pirvu, and this is my assessment for physics for computer graphics, final attempt. I will start by showing you the game, how it works, how every uh, object interact with each other and with the environment, the replayability, and all the physics involved in this project. I will show you how everything was created, how everything is connected between the game object to the object itself, and then to collider, and then to collider collision calculation, and how they are implemented. I will run the code, and I moved the the window a bit in this part so you can see um, the helping guide. So it says start by pressing R. When you have the caps lock on, it doesn't work. You need to have the caps lock off. You can move left, right. You can move forward with up arrow. If when you press G, it uses the force on the Z-axis just one time. When you press space, you can jump. When you press R, you can reset the game. And on and off the gutters by pressing C and X. I will just press R. The ball it appears. As you can see, it stays on the bowling lane, and I can press as many times as I want. I can go left and right. I can go in the gutters. They will push me back. I can even jump on them. I can toggle them on and off, and I can fall to the ground. I can press R to reset. Can toggle them back again. I will press G to just push me in front. Press the arrows to move the ball. The purpose of this mini game is to go at the end of the round and push the obstacles. If you touch one of those red boxes, they will reset the position in the game, as you can see. You can jump over them to show you how they interact. I'm sorry, I misspelled. And yes, I know they had for the moment a lot of force just because they interact with each other multiple times. As you can see, they interact even with the gutters. When you press R, they reset too. I'll go one more time. And yeah, this is my game with the physics implemented. I'll go through the code. I will start by showing I will start by showing the skeleton of this game, which is the game object. Here we have this one was already in the package that I've downloaded first, but I've added the collider. As you can see here, we get the collider of this object that is gonna be created. We have constructors, simple. We can go the CPP. We have again the constructors, colliders. We get the game objects collider with variables for the collider. We put them inside the collider. You can go to the cube. Cube is created from the game object. We have on them on the cube an ABB collider and the collision forces, but the collision forces is really empty. It's not being used because I'm calculating the forces inside the object. For the cube, we have an size x, y, and z. Um, the reason this is why I have those is because on the collider I will use them even though he's just a cube and it has a normal size. A couple of constructors, a collider. We create a collider and get the collider to the get the collider on the CPP. This one is really empty. With I've disabled those constructors. We have just a normal one. Where, as you can see, we have the size x equals size, and we put in the collider the size and the position. And here the is gonna be like this. We have two types. One with for the cubes that have length, width, and height, and this is the for those purposes. As you can see, size x equals size multiplied with size x. And for the normal cube, all of them are equal with size. This is the ABB collider CPP. In the hash, we have just the constructors. I can go through the gutter, which is the same, but this one has a different size for all of the parts along for all the parts length, height, and width. As you can see, we put them into the collider. The size X, size Y, and Z, the position. And we update the position of the cube with the position on the collider. Right here, we get the collider. Um, in the update here, after the position, it's a very simple toggle on and off. Um, we have two positions on the y-axis, one up, which is the this one, and one is under. And if press X, is going under. We cannot see it, and up. If it's up, it's on the uh, position that y equals 0. So if I press C, if I press C and the object, the gutter, is less than 0 0.3, and that means it's under, it's going up. If it's and I press X and it's up, then move it down. Um, the bowling lane, it's again simple, like the other sized cubes. We just get the collider and update the position for the collider. We have the pin that has the first object. We have two objects that has um, all the physics variables. As you can see, the normal one's mass, size, drag, force. We had the drag, it stops. It's like a friction. Um, Velocity, a new velocity to update it, new position, acceleration, gravity, create a collider, and the total force to update it, and the move speed. Two colliders. This one has more more variables, as you can see. Create a collider, and right here we have we have three more functions that I've created. You will see them in the CPP. Assign. Assign them the ones that I need to be 0. The gravity for this one it's 0.2, but for the pin that for the sphere that it's our player, it's minus 9.81. The drag force, add the variables into the collider needed, ABB, draw function, get the collider, calculate forces. Here is where all the forces are calculated. So as you can see, the acceleration is the total force divided by mass. New velocity equals velocity because we orbit it all the time, plus acceleration. And here is the drag and the gravity. total force. Total force is new total force is total force minus the total force multiplied with the drag. Um, velo Velocity equals new velocity. The same with position and reset forces. The way, we reset forces because the force is going to increase all the time, so we just need a push, not a continue acceleration for this. The same with the sphere. Really the same, just we have just a radius, not with size x, y, z. Air friction. This is used for the when it's falling. As you can see, the gravity is minus 9.81. Collider. The draw function. This is for the three main axes that appears as a debug right here. This is from the drawing helpful guide um, that uh, that it was in the folder. Okay, the collider, and again, uh, movement. This one has movement that we can interact. As you can see, the keys, we move the total force on the x-axis with the speed multiplied by mass and delta time. The same with going up, left, right. When I press G, I will, and the velocity needs to be greater than minus 2, just because we are going the minus z axis, so it's gonna be minus. It's gonna go on the minus the velocity. So not to press and spam the G button. I've implemented this too. You can press it when it slows down. So we put a total force on the Z for this amount. The same as the pin, we calculate the forces, reset the force. This one I've never used it because I used this total force. I wanted to add angular velocity, but I've never was able to implement it right, so I had some issues with it. So I just uh, get the calculation done, but it was hard for me to implement it, so I just let it here. As you know, we have two types of collider. We have the sphere collider and the ABB collider. The two constructors, ABB collider, sphere collider. Uh, in the main function, I'll go up. Here we have all the classes needed. We have the positions for the camera to update it. We have a new vector here for the start position because we need to restart the sphere and the pins. The starting text. All the objects placed here. We have one sphere. All the cubes in the middle that when we are touching them, they will return us in the start. All the pins at the end, the bowling lane, and the two gutters. All of them has the ones that need has size X, Y, Z, and mass. All of them has mass. We push back the object in the vector. Here we are looping through every object in this vector. If we find a pin, then we take his position and add it to the start position vector. So we can reset them at the start position every time. Right here I use this depth test to enable the depth because the sphere was always in front of everything. The cam position right here, it follows the z z position of the player, plus an offset, and it look like this. As you can see, it follows the z-axis and with a bit offset in the back and up. Here I've created a vector tree, so it's gonna be easier for me to reset the objects. Reset function. When you press R, the position and the velocity of the pins and sphere is resetted. When I press R, we increment the J with -1, just because when we find the first pin on this vector, we start with 0. It's gonna be the first spin. It's gonna take the position 0. The second, yeah, and on and on. The second is gonna take the 0 with 0, 1, and 1. The same as they entered in this vector. We I've reset their velocity with 0 again. If we find a sphere in the vector, then we turn it to position 0 and velocity 0. Right here, object path to collide check. Here we are moving, we are implementing all the objects from the vector to the collision check, to calculate all the responses between the objects. We instantiate a collision calculation class. Every object try to check the collision with every other object, but we have some checks here. So we loop we loop the objects, then we loop it again, just because the first object will look for all of them, for all the others, and then the second one will take through all the others, and so on. I have here a little this is for the restart position. As you can see, I've put it on paper so I can understand the logic um, behind the understanding of this. Right here, as you can see, uh, it's going the first one is gonna check for 2, 3, 4. The second one gonna go 2, 3, 4, 3, 1, 2, 4, and so on. Because we don't need 1 to 1, 2 with 2, and 3 with 3. This is why we have here I need to be different than J right here. So if we find a sphere on the first object and the second object is bowling lane, then we add them to sphere ABB collision, which is this one right here. I'll explain it after. The same with cube, gutter, uh, pins with the bowling lane will go to ABB ABB. Right here, I've put a second check. Uh, so the pins don't need to know every other object if they are not supposed to. Um, they will know. They will start checking the other objects when the sphere position is closer to the pins. When they hit a certain amount of position on the z-axis, and after that the pins will start to know about the gutter, the sphere, and the pins, the other pins. On the idle loop with all the functions that we have, and this is the main. On the collision calculation, this is where all the objects from the main are coming here. As you can see, we have an ABB, we have sphere ABB, ABB sphere, sphere sphere. We I've just used this the first two just because we are not taking sphere bowling lane and bowling lane sphere just one time, not back and forth. We are checking. I will go a bit on my papers to show some right here. This was before and after the as you can see the pins know just the bowling lane, not every other thing. And after the ball hits the this trigger, then all the pins will start knowing about the other pins, the gutter and the bowling, then the bowling ball. And right here I have the same thing but with more different schema, so I can do my hierarchy on paper and then on the code. As you can, the sphere knows about these objects, the pins knows about these objects. The jumpers are now the cubes that you don't need to hit. You can see they only know just about the sphere. Right here, some the same uh, the same drawing, but in a in a column. As you can see again, before and after, before the trigger and after the trigger, what was happening. As you can see, the ball is gonna when this was another approach. When the ball finds the pin, then pass it. But I'm not using this type of method. I'm using that one. Right here is the starting position code written on the paper. Um, I've every time I try to write it on the paper, and if it makes sense, then I started to write it as a code on C++. And right here, as you can see, we are starting to understand if we have three objects, one, two, and three, and we have all the possibilities: one with two, one with three, two and one, two and three, and all the rounds are unique, and the other ones are copies. As you can see, one, two, two, one. We don't need the second one. One, three, three, one. We don't need it, and the list goes on. The fourth um, the fourth formula is our position, but this one was a bit different because I was never mind. This is again with the objects going in the into the collision calculation. Right here in this check, yeah, enters only cubes. We On the D collider, we get the first objects collider, and we start checking. We start checking on the x-axis. If C plus his size is greater than this one and minus his size, we have these two objects. If this position plus size is greater than this position minus this size. As you can see on this axis, if we iterate like this one, it's bigger than this one. So it's collision. This is the collision. This is the thinking behind this line of code, and for every axis. Here we get the normal for two cuboids. Uh, the their position. Uh, the subtract the subtract. We put the second and the minus the first positions. We normalized normal. Restitution is a bounciness coefficient. If the restitution is zero, they are not losing any. When they collide, they are not using any uh, velocity. The distance between the two objects. So if we have collision, uh, and if the first object is spin and the second object is bowling lane, then we start doing this. Here we cancel the velocity with gravity, as you can see. We put the gravity right here. This is the plus gravity on up, and he's going down. They cancel in the middle. Pin gutter. This is an impulse coefficient because we have two gutters. There was I found a way to know which one is colliding, the one in the right or the one in the left. They have the position uh, 1 and -1. So if gutter B has the position bigger than 1, then we do on the left side the velocity minus equal impulse multiplied by mass, and the same with the other one. Um, as you can see, I have for uh, every important thing I have explanation, because I think it's important to have those things. The pins are using the relative velocity, which is their velocities, the subtract of their velocity. Impulse scalar is the restitution, the bounciness coefficient. Uh, the result in a scalar value that represents the degree of similarity or correlation between the two vectors. These two vectors. Then we divide it by their masses. And here, the velocity of the pin equals the relative velocity minus impulse scalar divided by 2. I've put this 2 by hand just because it was the greater force. Let's try to slow it a bit down. And then the mass multiply with the normalized. Uh, Sphere ABB. For sphere, we get the closest point on the cube. So we have the maximum point, the maximum point between this this one and the minimum between these two points for the all the axes. And then I put all the closest points into vector tree, so I can use it then in the calculations. The distance is the it's square root of the closest point minus the uh, C's position, which is the sphere. The same with every axis. Again, the normal, and this is why I use the vector 3 closest point, so I can use it here. This coefficient, if the distance is less than the radius, and we have the first object sphere and the second object cube, then we uh, move the first object sphere at this position, and we increment his velocity on the axis with 0. If the first object is sphere and the second object is bowling lane, then we have this impulse because we are for the jump button. This is for the jump button. If you press space, we are going up on the axis by using an impulse multiplied with his mass. Else, we are canceling the velocity on the a-axis because it's touching the bowling lane, so it's not falling. Sphere and gutter, we are using the same thing like with pin and pin with the relative velocity, and because we have two different gutters, I uh, I was supposed to give them a different values. Sphere pin, again the same story with relative velocity, impulse scalar, uh, and this works really nice. Um, this code here is supposed to be manipulated by the pins when they bounce back from other things to back to the sphere, but this is not working right now, so I will just let it here. These two functions are empty, and they are not empty. Ready to they are ready to be implemented, but I have no sphere or ABB sphere just because we have sphere ABB. I will present you sphere, which is about their positions and their radius. And this is like for a debug for me to understand it. Um, right here in my document, I've tried to understand everything how it works. As you can see, sphere, cube. I try to write to draw them to better understand them. As you see, here is a collision between a cube and a small sphere. I have all the axes, all the points, minimum, maximum, uh, how they interact, and they calculate this for this thing. The deflection I've added, and yes, I have some references from where I got some inspiration and help. They are just very common websites. I've uploaded uh, my uh, my assessment on the GitHub. Here I have all the documentation that needed to play the game, all the references. As you can see right now, it's private. It's 6:23 in Romania, 4:23 in UK. So in 2 hours it need to be already submitted. I will put it on public, so the person that looks into my assessment can get access, because I don't have access to you who to Coventry University GitHub. And if this is not working, right here it's a link for the Google Drive. Right here you can see that no one has access. Just this is the only link created. As you can see the detail. No one here is other person is here is created today at 12 p.m. UK time. Thank you for listening.